Hi, so just a quick video to demonstrate how quick and easy it is to set up some measurement checks using the Baumer profile sensor, the OXM series here. I'm just using a quick easy example here of a part with some steps on it, and I'm going to set up some checks on height and some delta heights just to show you the tools, how quick and easy it can be. So you can see the laser line profile across there, so it's a laser line profile sensor. So off we go. So all you need to get started is to connect the I/O cable here for your inputs and outputs, your Ethernet cable or power over Ethernet cable to do your communication, and connect to your PC to then set up the tools via the web interface. Okay, so now we've got the sensor mounted as we wish and looking at the part that we wish, we can now go into the web server via the IP address of the sensor 192.168.0250. The sensor will then give us the option to parameterize, add a old setup program, or add first tool and run through a wizard that way. So let's just start, and you can see we see the profile of the part underneath the sensor there. I'll just make it easier and only concentrate on the profile. I can now, via the web interface, just go in and optimize the profile output. So you can see it's a little bit noisy at points, maybe too much light, maybe too much exposure time, etc. I click optimize, and there you go, it straightens up and cleans up the laser line image for us, nice and easy. Okay, so let's go into the measurement tools, and like I said in the preamble, you have got access to all of these tools here. So if I wanted to simply measure the heights of those steps, or even the delta heights of those steps, I can do that using some height tools here. So I've just added a measurement tool over the whole field of view, so over the whole part itself, and it's giving me an average reading there. It's saying the average height is this hash line here is around 14.8 mil, but I'm not interested in that, so I just deselect that, and I just want to measure, say, the maximum height of, say, this step here. So I just change my field of view where I'm looking, which is there, and the step that I am talking about is this step here. So you can see I've entered the profile with my screwdriver, and that's the step that we're talking about there. So the step height for that is 14.4 mil, roughly 14.5 mil, let's say. And again, I can do that a number of different times, or I can even look for the delta height in that region. So the difference between the base here and the actual step itself. Will give us the output of that area there. Okay, we can do that a number of times for these different steps as well. So all we do is add another measurement tool here, and you can display down this sidebar here up to 7 different concurrent measurements. So in this case, if I wanted to do, say, the third step here, I can do that via this tool here. And that again is by using the maximum Z value and also the delta, and just change the field of view that I am looking at here. And so that's giving us the height here, of the part from the sensor, and also the delta height, so the difference between this and this. If I show you by putting the tools on, you can see the hashed line here, and also the hashed line here is where it's giving us our delta, and this moving hash line is giving us the maximum height of the part itself. Okay, so if I add just a couple more tools just to show you the capabilities of the outputs, I go to add measurement. Let's add the angle tool, let's say, and I want to see what the angle of the part is. So the angle of the part is saying that it's around 3 mil off perpendicular, so it might be just the way that I've set the sensor up, but just to exaggerate the situation, I'm tilting the part here up 10-15 degrees, let's say, and then back down again, and you can see the output as it goes with it over here. So back down to 2.6, 2.7 mil, and then back up to 10 or so degrees there. Okay, so we can set some tolerances for that later on when we're assigning the outputs, but just to show you what you can achieve from that, you can also do the angle in Z, which is the complete opposite in 90 degrees for it. So rather than this angle here, it will be this angle there. Okay, so we can go and quickly assign some outputs. So if I wanted to say set the digital output of which two we've got available to us for pass and fail, so just for a bit of poke-yoke, we can maybe assign it to the maximum height of distance tool 1, so that first step there, and say, right, the maximum height, let's say. And we can have this as a point or a window, so maybe we can have it as pass or fail, to say it's got to be above 15 mil to pass, so we're under it at the moment, and so let's say, right, 15 mil is the threshold. I want it to be 15 mil high before I get an output, for example. So it should be off at the moment, and here's output 1 there, and then say let's for output 2, let's select the delta distance 2, for example, so this second height, and we can say for a window, right, you can have anything between so we're reading 15.5 mil, so we can say anything between 15 mil to 16 mil is okay. Anything above that or below that is no good. And let's say for the analog output, we can say select, for example, the angle, and we can choose the type of analog output we want for that, and scale it over the degrees that we want, so say 0 to 25 degrees, for example. Okay, of course we can output the whole of the profile and make decisions somewhere else in the PLC with the data achieved, and not use any of the outputs or use them simultaneously. Okay, so let's see how we go. So we can now test the program that we've set up and see the outputs come on and off here in the corner of the web server, just for testing purposes. So if I wanted to introduce a height to that third step here, you can see I am now changing the delta height here, and you can see our output 2 has come on because we've come outside of the window. If I now take it away, you can see it's back to being okay again. If I do the same, say for the first step, introduce a different height, you can see now my output 1 is on because I've gone over the 16 mil that I said was the threshold. There we go. If I remove again, you can see we're back to OK and the output's on. If I now change the tilt of the part itself, you can see I'm setting tolerances of that also. And then if I lift the whole part all together, what sort of output I get. So the delta measurement is okay, but of course as I increase the height of the part, the measurement distance had changed and so not okay anymore. Okay, so nice and easy as that.
Okay, so just to summarize, the OXM sensor gives us the capability to do some quite interesting measurement tasks, profile output, and also simple pokeocto dependent on the dimensions of the part for heights, gaps, widths, whatever it may be, for any industry in a simple and easy way.